Q6c. Okay, this is more than or equal to 0, so it is not non-positive series. Okay? So we do need to check. Oops. The one with absolute value. So let's do this. First, limit test. Does it work? No, because the limit n tends to infinity of 1 over square root of n squared plus 1 is equal to 0, so there is no conclusion for limit test. So we cannot use limit test. For integral test, same thing. I will skip. Okay, I skip first. How about comparison test? This question looks like we can use comparison test, right? We can sort of compare with 1 over n 2 over 3, but let's see whether we can compare it directly or not. So we have one over square root 3 n squared plus 1. Actually, I forgot to mention, if you are doing comparison tests, you need to sort of guess whether this is convergent or diverges. You need to sort of guess a little bit, okay? Because the inequality you want to have depends on how you guess. Okay? I guess that this should diverge because this looks like 1 over square root degree 3. Looks like this, right? And this whole thing diverges. Okay, so if we want to use comparison test, we want the inequality sign to be like this. Okay, and I want this part, the summation of this part diverges. Then I can conclude that the summation of this diverges. Okay, so let's see whether it is actually more than or equal to this. But this is not true, right? It is very clear that this is not true because the below part is more than or equal to this. So this term here should be less than or equal to, right? And the summation of 1 over this diverges. So I cannot conclude anything. Okay, so there is still no conclusion here. So we still have no conclusion. So what should we do? Don't give up. Okay, it looks very similar to this, so let's make use of this trick. So I first take out n squared from the inside, 1 plus 1 over n squared, and I take this out, 1 over n power 2 over 3 square root 3 1 plus 1 over n squared. And we see that if n is more than or equal to 1, n squared is more than or equal to 1, Let me write it this way. If n is more than or equal to 1, then n squared is more than or equal to 1, then 1 over n squared is less than or equal to 1, then 1 plus 1 over n squared is less than or equal to 2, then we have this, then we have 1 over is more than or equal to. Which is very good because of this thing, I can say that this is more than or equal to 1 over 2 over 3. And now we have this is more than or equal to this, and the summation of this diverges. So I can make use of comparison test. Since the summation of 1 over and 2 over 3 and from 1 to infinity diverges, then by comparison test, the summation n from 1 to infinity 1 over 3 and 2 plus 1 also diverges. Okay, done. Alternatively, you can also use limit comparison test. Okay, it also works. And the thing that you compare with, it is also this one. Okay, it is also by using this series.